Well, hello there, and welcome back. I did not forget about student assignment. We didn't take a whole lot of notes on that first one. It was more information. So we'll be going through lesson 1.4 and 1.3 assignment. Okay, and you will see these functions. This one was written incorrect. It's supposed to be 0.1. Okay, so I will go fast and furious. Remember, you can always replay me. So I ask myself those three questions. Where is the x? So I look through this problem. There's an x here, and I'm going to use a different color. There's an x here, and there's an x here. Now remember, I have to circle what's with it. So I'm looking for the x, and if there's an exponent with it. Okay. So in this problem, there's two x's, but I take the one with the bigger exponent because this tells me what it is. Okay. It's raised to the second power, which makes it quadratic. Okay, I'm just going to abbreviate. It's quadratic. Now, I look at the number in front of it, and it tells me whether it is increasing or decreasing. This is the catch, because the number in front of it was negative 0.1. Okay, so it's negative 0.1 x to the squared. Now, some of you are going to read this as 11.5x minus, understanding that the minus and the negative always stay with the number after it. Okay, so this tells me that my quadratic is facing down. Okay, so I know both that it's quadratic and it's facing down, which means it's going to have a absolute maximum, correct? Absolute maximum. Okay, so it is down, quadratic family, absolute maximum. The domain is something we'll talk about in just a second. And the range is the same. Any number smaller than whatever this number is. Now, we don't have any numbers. We're not actually putting it on the graph. But on the work you have, you'll have to know. Now, here's the situation. It says a fitness company is selling DVDs for one of its cardio routines. Each DVD will sell for $15. Due to the fixed and variable costs, the profit of the company will see the selling X DVDs can be represented by the following function. So, we're selling DVDs. Is that continuous or discrete? So the rest of this we can get just from the sentence, from our function. When we read the problem, what are we measuring? Okay, this is what we're talking about before. We're measuring the sales of DVDs. Is that discrete or continuous? Hopefully you will know it is discrete. Okay, why is it discrete? It's discrete because you're selling DVDs. You can't sell half of a DVD. Okay? Because you're measuring specific individual things that can't have pieces, it's a discrete function. Which means, would it be a curve? Yes, it would, but it would be dotted. Okay, so you were able to tell what direction it went. You were able to tell what kind of function it was. Did it have an absolute maximum or minimum? In this case, it was a maximum. And was it discrete or continuous? This one is discrete. Okay, it could have been continuous if they had changed the scenario. Okay, the problem you're reading. That tells you whether it's discrete or continuous. This one's an easy one. Notice, I look at it and I see, oh, the x is by itself. There's no power. And there's three different problems, which means it's cut into pieces. Yes, it is linear piecewise. Okay. Not only is it linear piecewise, but I know all of these pieces are going in what direction? Well, let's see. Let's look at the number right in front of the x. All of them are positive. So that means my linear piecewise function will be going up. It may change rates, but it's always going up. So it'll be 3 lines that are going up. Okay? Now let's read the scenario. And when you read the scenario, you tell me whether it's discrete or continuous. Okay, so here we go. It says that you're parking a car and there's different rates depending on the number of hours you're there. So hopefully you understand that this would be, is this continuous or discrete? This one is continuous because you can have pieces of an hour. You can get charged for half an hour. Okay? It gives you an hourly rate. It's just like working a job. Even though you get paid $3 an hour, if you work 3.5 hours, you get paid for that half hour. You just don't get paid for the 3 hours. Okay? So it's continuous. So it was increasing. It was linear piecewise. It is continuous. Now it doesn't have an absolute maximum or minimum. No. In order for it to have a maximum or minimum, an absolute maximum or minimum, it must change directions. So there's only 2 graphs that change directions. Absolute value and quadratic. They're the only 2 with maximums and minimums. Maximums or minimums. All right, so we look at the third one. Here's the third problem. Hey, where is our exponent? Excuse me, where is our x? Well, this time it's in the exponent, which means this is exponential. That's an exponential function. It's in the exponent. Obviously, the name tells me it's exponential. And then I look right in front of it. There's no power. So that means it's positive. That means my exponential is increasing. It goes like this. It's increasing. Okay, if it was decreasing, it would go like this. And I'll show you down here. It would decrease. That's what decreasing looks like. Exponentially, it looks like this. My drawing sucks. Sorry. But right now, it's increasing. Exponential increasing. Does it have a maximum or minimum? No, because the only 2 that do are quadratic and absolute value. Is it continuous or discrete? Well, read the scenario and you tell me whether you think the information there is going to be continuous or discrete. Okay, hopefully you know it is discrete. Now, one of the reasons why it's discrete is because interest is paid in years. And that's a banking thing, meaning until it's there for the full year, you don't get all of the interest. Now, if it was paid quarterly and you were there for years, quarterly means it's part of the year. So that means, yes, you would get paid for it. But if they're paying yearly interest, that means they only pay it at the end of the year. So if you leave early, you don't get the interest. So that's why it's discrete. It's only every year. Okay? So this one would actually look with dots. All right? Okay, so we look at problem number 4. And we go, where is the x? We found an x. Okay, and then we look in front of it. Remember, this sign goes with that number. So this is a negative 200. So the x by itself, it's not an exponent. There's nothing power raised. Okay, so this means it's linear. This is linear. And the negative sign tells me that it's decreasing. Okay? Linear and decreasing. Then you look up and see if it's continuous or discrete. Problem 5. Now we see our absolute value signs. Where's the x? The x is in the absolute value signs. So this is a v. Okay? And we know it's going to be a V because the X is inside the absolute value. Does it go up or down? I look right outside of the absolute value sign. It's positive, so that means it goes up. I look at this one. Where's my X? It's in the absolute value sign, so it's an absolute value function. Then I look right outside, and you have to remember that sign stays with that number. It's very easy to get confused. That one says -2, which means that V goes upside down. This one has an absolute, correct, minimum. This one has an absolute, correct, maximum. And you will see all the information you have to fill out on your assignment sheet because you've hopefully printed it out. And you will see that this would be called an absolute value function. And it's decreasing then increasing. This one's increasing then decreasing. Okay. This one is increasing. It's a curve. This one's decreasing, it's a line. These are both lines. There's just two of them. This is a curve. This is a line, thus linear. Okay. So knowing what is a line, what is a curve, what is increasing, what is decreasing. These are all things that you're going to get just from the function. It's going to take some practice and studying. But being able to identify the function families is something that you have to be able to do. Okay. And then the last thing was figuring out discrete and continuous and understanding that discrete is information that's measured in individual pieces that can't be cut into pieces. Okay, like the number of people, the number of cars, and in this one case, it was the number of DVDs. This is a reading. You have to understand what you're counting. So if I said the time to run the 40, hopefully you understand that would be continuous because you can have it in sections. All right. Have a good week. We'll see these notes on Friday. You'll be using them all throughout the week, though, as well. I will check them on Friday.